Hello and welcome to Kira Tech Hub. My name is Paulina Mwakira, and in this video, we are actually diving more into networking. So we'll be focusing on visibility, understanding who can talk to what in our AWS network, and whether that access is intentional. So this is a first video in a short series. We'll start with the Network Access Analyzer, and then in the next video, we'll go into the Reachability Analyzer. And then finally, we'll just dive a little bit into the Network Manager, AWS Network Manager, see that how that works and which question that answers. So we'll get started with the Network Access Analyzer. This is more of a beginner to intermediate level workshop or lab hands-on activity, and you're going to be utilizing the US East 1 region in our demo. So when we think about it, most AWS environments don't become insecure overnight. So this insecurity increases, gradually. Maybe we add a rule over here, we attach a gateway, a firewall exception someone forgot about in that case. So the Network Access Analyzer actually helps us see the actual access path and not just the individual roles of what is going to happen in that case. And one thing to note is, if something looks secure, that doesn't mean that it's secure physically. So what you're trying to answer with the AWS Network Access Analyzer, we are trying to ask some questions like what resources are reachable over the internet? Are our environments segmented properly? Is traffic flowing how we want it to, through the required security controls? Are there any workloads that are restricted to trusted destinations in that case? So think of this tool as asking what could talk to what if it tried, It's not about packets, it's not about logs, but the possible network paths based on the configuration that we have set up. So where the with regards to these network visibility tools that I said you are going to talk about. So today's tool or right now's tool, basically the Network Access Analyzer, is more of a preventive and governance focused tool. So who can access what? And then the next one, the Reachability Analyzer. We are trying to answer the question, why can this connect or why can't this connect? So here it's more of a why. And the Network Manager, which will be the last video as part of this series, is just to get a centralized network view of our architecture in that case. So these tools complement each other, but they do answer different questions. So what the Network Access Analyzer is really about is more about static analysis. So just to get that clear, static analysis, it's not about live traffic, not live traffic in that case. So it doesn't matter whether something has been accessed, only whether it could be, in that case. So we analyze our network configuration, possible network paths, and then it's gonna flag any unintended or any non-compliant access that we have. And this can work across multiple of our networking services. So the virtual private clouds, our transit gateway, our internet gateways, our firewalls, and so on. If we go a little bit into the mental model of this, the Network Access Analyzer mentally walks a packet through your architecture and checks if a valid path exists in that case. So if it does, you're going to get a finding that, okay, a valid path exists through our architecture. So if a packet started at this point in time, could it reach the second point? Based on my current setup, based on my routes, based on my gateways, attachment, firewalls, any security boundaries in that case. So that's it. That is just an introduction of the Network Access Analyzer. So let's get a little bit hands-on and see how this basically works on the management console. So in our hands-on exercise, we'll do different parts of this. But before we get started, we have to set up our architecture. Don't be alarmed. So this is the architecture we are basically going to deal with. And I have this cloud formation template that is a mirror of the architecture diagram that I have shown you. So this cloud formation template, it's not really the best because we have basically had coded some values, which basically means this template is going to work in the US East 1 region. We could do better yeah, and make it more dynamic, okay? But just for the demo purposes, I mean, yeah, you can forgive me for that. And I'll share a link on where to get this template. It's just part of a AWS Workshop Studio. So it has a lot of parameters and lots of resources, which are basically this. So what I'm going to do is use CloudFormation to launch this template. And while it launches, I'm going to come back and try explain this architecture just to save on time over here. Okay, so CloudFormation, where are you? Okay, so let's create a stack with new resources. I'm gonna choose an existing template, which is downloaded, and I'll share the link on the description. Okay. Okay. Stack details, Kira, network stack. I think that's cool. And the parameters. So availability is on 1A, 1B, the instance type for our web server. We'll see all this in a moment. And I think I don't need anything much. I acknowledge that CloudFormation is going to create some resources for me. Next, and submit. Okay, so while the CloudFormation template is creating our resources, which will take some time, let's just have an overview of some of the resources that we're trying to create in this case. So if we start this architecture, the big picture of what this architecture is doing. So as you can see, this architecture is using multiple VPCs. We have the production VPC. Maybe I need to change the color of the pen. So we have the production VPC, inspection VPC, central egress, and dev VPC. All these VPCs are connected together by the AWS Transit Gateway to just enforce some strong network security control. The main idea over here is our workloads live in separate VPCs. All traffic is centrally inspected from the inspection VPC, and internet access is tightly controlled from this architecture. Nothing talks directly to the internet unless it's explicitly allowed and inspected in this case. So diving in a little bit deeper, we can see on our left side, we do have the production VPC over here and the development VPC. These VPCs contain our application workloads, each VPC. So we can see we have some EC2 instances in this case. What you can realize is these VPCs do not have an internet gateway. So these are private subnets only. Both VPCs send all non-local traffic. So you can see the route tables. Non-local traffic, you're saying, do not send to the internet gateway, but to the transit gateway. And that means that the development and production environment are isolated. They don't have direct internet access, and there is no accidental cross-environment communication in that case. Now, moving on to the transit gateway at the center. So the transit gateway is the traffic director in this case. It sits in the middle and connects all the 4 VPCs in this case. And it's using different route tables. You can see each VPC has its own route table, which control how the VPCs can talk to each other, where the traffic is sent next, which paths are allowed, which paths are blocked in that case. So this is where the network segmentation happens. For example, as you can see, from these route tables, all the non-local traffic is being sent to the transit gateway. But then again from here, for the prod and the dev route tables, all non-local traffic after coming here is basically redirected for inspection within the inspection VPC. So that is basically it, and more rules again. For the inspection VPC on the top right, as we can see, all traffic is going to pass through here before going anywhere else. What we can see over here, we have this firewall endpoint. So the inspection VPC actually contains the network firewall, AWS Network Firewall. It has some firewall endpoints and also a transit gateway attachment. Any traffic that leaves production or dev goes to the internet or process environment must pass through this firewall first. And what you're trying to ensure in this case is we do have some centralized security policy enforcement. no firewalls bypass any paths, and there is consistent inspection for all traffic going through our environment. And the other VPC over here, we have the central egress VPC. And what you can notice over here is, where's that internet gateway? Somewhere. NAT. Okay, so here in our routes, maybe it's, oh, here. Oh God, why would I not see that? So the internet gateway is here. So from what you can realize is, this is the only place where internet access exists. So it's the only VPC with a NAT gateway. And we know the purpose of the NAT gateway being enabling, by textbook definition, enabling our resources in the private subnets to access the internet. And the NAT gateway only allows egress, traffic. So no traffic can be literally initiated from the internet. So we do see this is the only VPC with the NAT gateway and the internet gateway performing network address translation. So all outbound internet traffic comes from prod or dev VPC. They first go through, you can see the path, they first go through the inspection VPC, they go through the firewall, they reach the NAT gateway and exit via the internet gateway. So yeah, this design prevents direct internet access, makes outbound traffic observable, and also simplifies some sort of auditing in this case. So this is just the architecture that we have available. This design is actually secure because we have strong environment isolation. Our traffic is inspected, it's mandatory for our traffic to be inspected. And then we have like centralized egress egress control in that case. So even if someone misconfigures maybe a subnet or a security group, the network architecture is still protecting you anyway. And why the network access analyzer? Where is the network access analyzer coming in all this architecture? The network access analyzer becomes very powerful because within this architecture, it's honestly a huge one. And the network access analyzer can verify who can reach what. We want to do some verification. We want to verify there are no unintended paths. And we want to verify who can reach what with the network access analyzer. So we ensure traffic really flows through the transit gateway to the firewall to central egress. So instead of guessing, we want to prove that the architecture is behaving as we have intended it. So that's basically it about this architecture. Now, let's take a look at our CloudFormation stack and see if our resources are ready. Cool. Too much talking. Great. Complete. And yeah, we have a couple of resources being created over here. We can see some security groups, the internet gateway attachments, the subnets for the central egress, the dev resources. We have the transit gateway resources and associations being created, the inspection firewall resources as well. We had some databases in the prod environment, and so on. So these are the resources that are part of our architecture. So let's go ahead and start working with the VPC network analyzer. So we have some set of configurations that we'll be working with. Now, just going back to the slides a little bit. So the first part of what we're trying to achieve over here is our baseline security question. What in my account is internet accessible right now? And we're going to use the network access analyzer to, try and answer this, because even in mature environments, we are often surprised by the answer. So we're trying to verify which resources are accessible from the internet through the internet gateways and whether that exposure is intended or not intended. Okay, so let's go ahead and set up the network access analyzer from the console. So VPC. And as I mentioned from the start, I'm working from the North Virginia region in this case. And remember, we created like 4 VPCs, and we know we have a limit of 5 VPCs per region. So make sure if you're running this workshop, at least that region has enough space to hold the 4 more VPCs in that case. Okay, So under our VPCs, we are going to scroll at the bottom, and then we have this link to the network manager. Then under security and governance, we do have the network access analyzer. So if you're doing this for the first time, you'll just get a link somewhere to which says get started or something, and then you'll click on that. But because I had enabled this before, so I have this page. Maybe let me see if I switch the region. Maybe I can get the link to Oregon. Let's see. Yeah. So when you do this for the first time, you're going to just click get started in this case, and you're going to get like 4 network scopes that are created for you. And you can see the descriptions of what exactly these do. So, and you can use them to analyze them. So for example, the first one over here, AWS VPC address. It identifies egress paths to internet gateways, peering connections, VPC endpoints, blah, 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 from all our VPCs. But we'll be creating these network scopes so that we can understand better. So that is what you'll do that is what you'll see if you're doing this for the first time. And once you're done, you can, uh, just go ahead and use that. So because I don't have any resources in that region, I've just switched back to the North Virginia region, and we can try, for example, with this one. It's also Amazon created. Identify ingress paths from internet gateway to all network interfaces. So we can take a look at that just to test and say, let's try and analyze that. Okay, so we have at least one finding over there for our web instance, for example, in that case. And each finding that you get is going to show you like a network path from the internet through the internet gateway to the resource in AWS. For example, that resource could be an EC2 instance. And here is where you can review each finding, flag whatever you need to flag or take actions for, paths that you didn't, want access to. So you can scroll down and you can click on the resource even to see the additional resources on how traffic is going to basically travel. So you can see here from the central egress VPC internet gateway, we can see the roles, what is the destination address for a server. We can see the network access control list that, allowed traffic in. So it had this rule, allow all traffic in. And then we had the instance security group. And when you click on that, you can actually go to the specific resource to view additional information on that specific resource, which also allowed, port 80 access from the internet, and finally how the traffic got to our server in this case. So here we have seen how we can enable Amazon VPC Network Access Analyzer and use a default network access scope. So this is called a network access scope to analyze the ingress traffic paths from the internet gateway. So this analysis, helps us identify and validate any internet accessible resources in our VPC environment. Let's try something else. So in the next section, that was part 1 concept. Part 2 concept, let's try see how it works when you do some network segmentation. So segmentation is very foundational for security. If dev can reach production when it shouldn't, that is a serious design flaw. Okay, so here we can also use the network access analyzer to validate our architecture intent. So it's not just about the firewall rules. Is our architecture acting as we intended it to be? So in this case, what we are verifying, the prod endeavor isolated, there is no unintended east-west traffic in that case, and only approved VPC to VPC communication exists. So back to our demo. So over here, we'll be creating our own network access scope. And let's see. So this one will be for validating network segmentation. And you can see we have a couple of them. Identify access from internet or to internet, access from trusted networks, non-permissible traffic type. So we can create templates from all these or build your own basically. So let's validate network segmentation. Okay, and give it a name. I'm not good at naming. Kira network access scope 1. That will do. Description is optional. So let's just move on. Okay. So under the match conditions in this case, for the resource, we can use the resource type or the resource ID. So I'll go under the resource ID and then select the transit gateway attachments. And let's see the resource ID. So the dev VPC transit gateway attachment. And we are trying to figure out if this traffic can go to the prod. Yeah. So transit gateway attachment, and then this will be for prod. And then I think that's it. Next. And create the network access scope. So here it is. And once it's created, so we can click on it and basically analyze. Cool. So as you can see, no findings were detected, which confirms that our VPCs in our prod and our dev environment are segmented and traffic cannot route between them. Now, let's create another network access scope to verify if traffic from our dev VPC can actually reach the network firewall, which is in our inspection VPC in this case. So to make our work easier, we can easily clone this one that we created and duplicate and modify it. And this will be the Kira. Yeah, I swear my naming convention sucks and hurts, but it's okay. Kira network access scope. This will be 2, or I can say it's a clone of one clone. And so this one for the dev VPC. And now I can change this for prod and say I want to see if it can reach the inspection transit gateway attachment. So duplicate and analyze. Here it is. Okay, so in our previous one, we saw there were no findings detected, which was actually our intended network architecture. But here, trying to see if our maybe let me go back to our architecture. So trying to see if our dev VPC can access the inspection VPC basically. Here, dev cannot communicate with prod, but dev should be able to access the inspection VPC. That is why there was a finding detected in this case. So just going back, we can see some details about that specific finding. So we had lots of findings depending on the traffic that was sent. And oopsies, I clicked on the resource. So I can check on that, and you can see information about how the traffic was going through, which route tables allowed for that. You can see the destination CIDR block and so on. All the information is available over there. And of course, when you click on a specific resource, you'll have information on the resource ID in case you need to make any edits. The other thing we can try, so we have tried internet exposure, network segmentation. The part 3 is on security controls in the path. So security controls would only work if traffic actually goes through them. But so here we're trying to answer, is there anything sneaking around my firewall without me realizing it? So we are going to verify that internet bound traffic actually, flows through the network firewall, and then through the inspection VPC or the NAT VPC in that case, and there are no firewall bypass paths in that case. Okay, so let's create a new network access scope. So create one, and this one is more about, I'll start with an empty one to do whatever I want. So just to see how to build your own. And this will be 2, network access scope 2. Okay. And and we're going to use like the match a specific condition. So match condition under resource ID, resource type, VPCs, and the resource ID. So I'll select both prod and the dev VPC. And then for the destination, resource types, internet gateways, okay, should be resource ID, sorry, internet gateway. And then I select my central egress internet gateway under the resource IDs available. So it's just that we check if the traffic is flowing to the internet, is it basically going through the firewalls that we have set up, or is it going through the inspection? So next, and create our network access scope. And then we can analyze. Okay, my analysis is complete now. So let's see, some findings have been detected in this case for both the prod and the dev instance. So let's check at the prod instance. What you're going to notice over here, this is a long one. But somewhere in this route, you can see the traffic is first going through the firewall. So they have a route through the network firewall. So that means that it has to go through the inspection VPC. And yeah, so we can see, let's see how it moves. So this was the prod, the ENI of our EC2 instance through the security group. We check the network access control list, we check the route table, and then it moved through the transit gateway where it was basically sent to the inspection. It was checked against the production inspection route table, which is attached to the transit gateway. Blah blah blah, and then the traffic was basically forwarded to the route table of the inspection transit gateway in that case. So the traffic basically went through the inspection VPC, whereby it was checked through the AWS network firewall that we have set up in that case before it was actually sent again from the inspection route table to the central egress VPC in that case, and that is how traffic reached the internet. So you can see the complete path ending at the central egress VPC transit gateway in this case. And that is what we wanted. And you can, to identify any paths that bypass the network firewall and potentially violate like the compliance requirement, you can actually create a network access scope to check on that. So now we'll use the exclude. So you'll notice when we created our network access scope, we said we basically want to see how our traffic is going through. So now we can basically check which ones bypass or violate our compliance requirements. So enough talking, more doing. Back to this. So I'm gonna create a clone of this again. Here are network access 2, actions, duplicate and modify. Here are so this is a clone. Okay. And so if you find any matching conditions, now let's check. Let's add an exclusion condition. So exclude condition in this case. Resources. So want to exclude any traffic. Is there any traffic that is going through? Exclude any any resources that are sending traffic, and that traffic is not going through the network firewall. So in that case, I'm gonna go to the resource types and then say the AWS network firewall and duplicate and analyze. Awesome, awesome. Okay, so as you can see, the analysis shows that there are no findings, which is actually, the expected configuration. All traffic from both prod and dev VPC are routing correctly through the network firewall, basically adhering to the compliance requirements that we specified. Oh, and last thing on this network access analyzer thingy. So we just see a final thing, how it works. The last step, part 4, is basically trusted network access. So think about, this is more about the concept of least privilege for networks. So even outbound traffic can be dangerous if we are not restricting it. So we want to ensure that our workloads are only talk to what they are supposed to talk to. Okay, so what you are verifying, outbound. So we have verified inbound. Outbound traffic is also restricted or only from approved IP ranges, only approved ports and protocols. So let's try that out, at least to find a whole overview of how the network access analyzer works. Back to the console, let's create a file, another network access scope. And then we want to identify access to internet gateway in this case. So next. And then this I'll call it Kiran Network Access Scope 3. Okay, that's cool. Let's see. So under resources, we can specify resource IDs, which are EC2 instances. What did I do? Okay, EC2 instances and the resource IDs, and basically choose the prod instance in this case under the resource ID. And then the destination. So our prod instance moving towards the resource type being the internet gateway. And then we'll add an exclusion condition. So we want to accept only if the destination address is a specific IP. So under exclusion condition, the destination, destination, the destination traffic type. So destination address, I'll just put this is part of our roles, /16. Okay. And the destination port is secure. So we can say 443. And the traffic type is TCP traffic. So we have just added an exclusion condition. Identify all traffic from our prod environment going through the internet gateway and exclude this one. If the traffic is going through this destination IP address, destination port, and it's a TCP type of traffic, then go ahead and exclude that. So it's just that. Next. Okay, we are excluding this part. Let me create that. And let's analyze. Awesome, awesome. A few moments later. Okay. So there's some findings which have been detected. Let's see. And we can see traffic is basically moving from our prod VPC to the internet. And that means that there is a network path that exists between our EC2 instance and the internet gateway beyond our defined restriction. And if we check at our current, for example, security group configuration, so you can see like our current instance security group, outbound, destination outbound allows all traffic, like all TCP traffic in that case. So which is broader than the policy, which we're trying to limit traffic to a specific IP range and port. So we can go ahead and check on this security group. So we'll click on that. the outbound rules, let's do some editing. So instead of allowing it from anywhere, allowing all outbound traffic from anywhere, we can specify the IP range that we had before. So it was 53.3.00/16. And save our rules. And we can just go ahead and analyze again now that we have edited our rules. And yep, now no findings detected. So we have used like the network access analyzer to examine outbound internet access, traffic paths, and through the initial analysis and then subsequent security group modifications, we have verified that our outbound traffic is now properly restricted to the specific IP range and port that we wanted, just ensuring compliance and security and requirements. So I think that's it. Just more features I wanted to mention. What a finding means. So it's just a clarification. A finding is not equal to an attack, okay? Like it's just telling you, this tool doesn't tell you, oh, this is bad. It's just telling you it exists. So there is a possible access path, and it's your judgment. The security judgment still belongs to you. You are the one to decide if this is intended access acceptable or a risk. Now, when we use the network access analyzer, so it's just think of it as something you run before you go live, after a big network change, and maybe during security reviews in that case. So some of the key takeaways, I just said this tool helps you to answer one powerful question. Does my network behave the way I think it does? Does my network behave the way I think it does? Okay, so you get visibility, you can get access paths. It shows you the intent of your network versus the reality of your network, and then you can fix issues before any incident. So that's it for the network access analyzer. In the next video, I'll be introducing the reachability analyzer. So now that we know what could connect, the next step is understanding why something can't connect, okay? Why something can't, why connections succeed or fail. This is where the reachability analyzer, shines, identifying the exact blocking component. So thank you so much for watching this and see you in the next video. Bye-bye.